Okay, so just we missed the first little bit here. I'll explain it again. When vectors are perpendicular, the dot product will equal 0. So we take, we name this vector v, this vector w. We multiply them together to get 2x squared plus 2x plus 5x minus 15, set it equal to 0. So when simplified, this is the equation that we're looking for. All right, any questions on that? Okay, so for part B, how would we go about finding the two values of x? How do you solve 0 equals 2x squared plus 7x minus 15? Factor it. So it's going to be 0 equals 2x, x, so x is going to be 3 over 2 or negative 5. So those will be the two values of x that would make two perpendicular vectors. Now, if that expression was not factorable, then what would you do? Quadratic formula, yeah. The quadrilateral OABC has vertices with coordinates O, A, B, and C. Find the vectors OB and AC. Now, I find these easier if you if you draw a picture. Okay, so that's what we're going to do. And in case you guys are wondering why we're laughing right now, it's because the Titanic is blasting next door. Okay, so the origin is at 0, 0. A is at 5, 1. And your diagram does not have to be perfect. 10, 5, 5, 7, 8, 9, 10, and 5, 2, 3, 4, 5. And then C is at 2, 7. So that's going to be up here somewhere. So we have A, B, C, and O. All right, so vector OB is this one. So we want to start at O and go to B. So vector OB is going to equal 0, 0 plus 10, 5. And this is what we did in the last class. So it's going to be 10, 5 as a vector. And AC, did I start taping? Yeah, I did. Okay. AC is going to be vector OC minus OA. I think the people probably watching this video can hear the Titanic right now. Okay, so we've got vector OC, which is 2, 7, minus OA, which is 5, 1. And if we subtract them, we get negative 3, 6. And I'm sure you've probably noticed this with IB questions. Very often what you do in A is going to come up in B. So having calculated OB and AC is going to help us over here. Okay. Okay, so then question B says, find the angle between the diagonals of the quadrilateral OABC. So the diagonals are OB and AC, which are what we calculated in A. So we want to find the angle between them. Now, with quadrilaterals, and not always, but this one looks like they're perpendicular, but my diagram is completely wonky, so it could or could not be. But if we want to calculate the angle between the diagonals, we basically want to calculate the angle between OB and AC. And to do that, we use the formula cos theta equals, I'm going to make sure I'm writing these down right, OB dot AC over the length of OB times the length of AC. Okay, so to find the angle between the diagonals of the quadrilateral, we set up the equation. So it's going to be cos theta equals, now OB, the dot product of OB times AC, that's going to be, we have OB equals 10 5, and AC equals negative 3 6. So you go 10 times negative 3 gives you, I want to do this, negative 30 plus 5 times 6 gives you 30. Now at this point you see a 0 on top. You could technically stop here because if you've got a 0 in the numerator, it doesn't matter what this is down here, it's going to be 0. And when cos theta equals 0, then theta equals 90 degrees. So that's the angle between the diagonals of that quadrilateral. Yeah, we won't worry about calculating the denominator because that comes up in the next couple of questions.